Now let's start working with task 2. Here we are given an integral and 4 segments to work with. So we have to compute an approximation of the integral here using multiple segment Simpson's 1/3 rule. Even if someone did not say you that this is multiple segment Simpson's 1/3 rule, but just mentioned to you Simpson's 1/3 rule, but n is equal to 4, so the number of segments is more than 2, you should know that you're using multiple segment Simpson's 1/3 rule formula. Okay, and after that we have to compute the absolute relative true error. So let's start working on this. So the integral that's given to us is integration from 2 to 3 1 over x plus 1 dx, and the number of segments is equal to 4. Now writing down the integration formula for multiple segment Simpson's 1/3 rule is from a to b of the function f of x dx is equal to or approximately equal to h over 3 times f of x0. So you can say that we are replacing here the a with x0 and the b with xn. So here we have f of x0 plus 4 times sigma, the summation from I is equal to 1 till n minus 1, f of xi, and here the I is odd always, plus we have 2 times summation from I is equal to 2 until n minus 2, and here the I is even always, f of xi, and then we have at the end plus the last x, which is xn. So that's the formula for the multiple segment Simpson's 1/3 rule. Now for this one here we need the values of, let's say, x0, or that is your a, which is equal to 2. Then we have b, which is equal to xn, that is equal to 3, and then h is b minus a divided by n. So here we have b is 3 minus 2 divided by n is 4, which is 1 over 4, that's equal to 0.25. Now for the n segments we have to divide the x-axis from x0 to xn unequal times. So we can calculate the x-coordinates by the formula xk is equal to a plus k times h. So here the first one is x0. So we know already x0 is equal to 2, but just with the formula again we have a, which is again equal to x0, plus k is the value here, so that's 0 times 0.25, so that's equal to 2 again. And we have x1 is 2 plus k is 1 here, that's the value of the x sub, so 1 times 0.25 is equal to 2.25. And then we'll find out for x2, the value is 2 plus 2 times 0.25, that's equal to 2.5. So we do this until we reach our b, which is 3, right? So we have x3 now, which is 2 plus 3 times 0.25, so that will give us 2.75, and then we have x4, which is 2 plus 4 times 0.25, that's equal to 3. So we have reached our b, or the xn, which is 3. Once we are done with this, we can stop finding out x values because we have finished dividing it to n equal segments here. what we can do to make the calculations easier is that we can find out already what is f of x0, what is f of x1, and so on, x2, f of x3, and f of x4. So this here you will get if you put in the value of x0 inside our function, so it will be 1 over 0 plus 1, sorry, not 0, x0 is 2, so here we have 2, so that will give us the value 0.3333, and then we can continue doing this. For this one here we'll have x1 value is 2.25. Instead of x, we'll put in the value and add 1. This will give us 0.3077, and then for the next ones we'll have 1 over 2.5 plus 1. This gives us 0.2857, and here we have 1 over 2.75 plus 1. This is equal to 0.2667, and here we have finally 3 plus 1, so this is giving us 0.25. So once we got all of these values, it is more simple to do the calculations. I'll just copy again this one here, the formula. Okay. And paste it here. Now if we work it out, so the derivative that we are searching for is from 2 to 3, 1 over x plus 1 dx, and this is approximately equal to h, which is 0.25 divided by 3 of f of x0 plus 4 times we have all the I is equal to odd xi values. So we know that f of x0 and f of xn doesn't fall into this odd and even, so leaving those which are the odd, so leaving this one here and this one here which are the odd, so we can see that x1 is odd and x3 is odd, so we'll take those two. So we have f of x1 plus f of x3, those are the odd ones here, plus we have 2 times, now we'll take all the x values which are even. So again, leaving x0 and x4, the only even is x2 here, so we'll only take f of x2 here plus the last one, that is f of xn. So we are done with creating our equation, and now this is equal to 0.25 divided by 3, and we already know the values for f of x0 and all, so we will replace here with these values here. So f of x0 is 0.3333, so we have here 0.3333 plus 4 times we have the values here as 0.3077 plus 0.2667 plus 2 times we have f of x2, the value of which is 0.2 0.857 plus we have f of xn, which is 0.25. so this, if you calculate, you will get the value as 0.2876916667. so that's the approximated value using Simpson's 1/3 rule or multiple segment Simpson's 1/3 rule. So the next step that we have to do is to calculate the absolute relative error. For that, we need to find out the exact value of this integral. So the integral given to us is from 2 to 3. We have 1 over x plus 1 dx. So let me rewrite the 3, it's not clear. So it's 3 here. Now let's say that u is equal to x plus 1, and then finding out the derivative of this one here, du by dx will be equal to 1, and then taking dx to the other side will give us du is equal to dx. And then we can say that the integration is of 1 over u, replacing x plus 1 by u, and here the dx will be replaced by du because we said here that the dx is equal to du. So this is equal to ln u, and then replacing u with x plus 1 again, so you will have ln of x plus 1. So this one you can finally write as ln of absolute value x plus 1 absolute plus some constant c. Now if you want to integrate it in the boundary of 2 to 3, we will have to write it like this. So we'll have ln of x plus 1 will be integrated from 2 to 3. So that will be ln of x value as 3 plus 1 is 4, minus we'll have ln of 2 plus 1, so that will be ln 4 minus ln 3, which is equal to 0.286725. So now we got the true value here, and we got our approximated value here. So we can use this to find out the absolute relative error, absolute relative true error, which is equal to absolute value of true value minus the approximated value over the true value times 100. So we have here the true value is 0.2876820.725 minus 0.28769 divided by 0.2876820.725. Absolute of the value here times 100, that gives us 0.00333% error.